Alright, in this video I'm going to make a little supplement to show how we can do these calculations in Excel. And this was our hysteresis loop calculation example that we had 0 to 500 megapascals down to minus 200, plus 200, minus 100, and then back to 500. We have our monotonic and our branch equation there that we'll use. And this is the kind of the sketch that I came up with at the end, and maybe we can make this look a little bit nicer in Excel. Alright, so the first part I'm going to do, I got my material properties in the spreadsheet already. The first part is we want a monotonic branch from 0 to 500 megapascals. So if we remember our monotonic equation, we want to calculate epsilon, and we want a stress that goes from 0 to 500 megapascals. Let's maybe, I don't know, maybe to make every 10 megapascals. Let's see if we can get this to do what we want. If we come down here to 500, okay, so that'll be the values for that branch. Now the reason why I'm putting epsilon to the left over here is so that the plot will be an x versus y type plot. So we'll use our initial Ramberg-Osgood equation. Alright, so if you remember what that is, then maybe I can make another sheet here. I'm going to grab a little screenshot so we can flip back and forth. Our initial monotonic equation to be epsilon is equal to sigma over E plus sigma over K prime to the 1 over N prime power. Alright, so my strain then plus sigma over E. The dollar signs, if you're not familiar with Excel, hold that value when we copy and paste this equation, plus sigma over K prime to the 1 over N prime. Okay, we'll paste those values, and now let's make a plot. Maybe we can put it over here. We might have to move it when we have enough branches. So let's insert one of these type of plots. The x values will be here. And the y values will be here. And that will be our initial stress strain curve. And you know, I won't pretty this up too much, but we can get rid of some of these things, and we can put stress versus strain, and we can put the units on it, which you should do, but I'm not going to do that at this point. Maybe at the end I'll do that. Alright, so that looks good. So now the next thing we had was the branch from AB. Let's see. And my starting strain value is going to be this value. So I'm going to copy, I'm going to paste that value right there. So my stress is going to start at 500. Yeah, it's going to start at 500. It's going to go down to minus 200. All right, got a little carried away there. And now we're going to use the branch equation. Okay, so it's I'm gonna have the 2 multiplied by all these terms, so it's going to be delta sigma over E. Okay, now we're going to have to change something here. We want the delta sigma. So it's the change from 500 megapascals. So let's put the 500 right here. Let me redo this equation. Okay, so this is going to be the stress value, and what we're going to have here is the strain value. Maybe to make this more clear, let me do this. This will be the stress. This will be the strain value. What I'm going to have here is the delta stress value. That is going to be this value minus this one. And the delta strain value, then we'll use our hysteresis branch equation. The delta strain value is going to be delta sigma over E plus delta sigma over 2 over K prime all of that to the 1 over N prime and then I need to take all of that and multiply it by 2. And I'm surprised I got anything there since delta sigma was equal to 0. Let's see what I did here. There's a sigma in there. This should have been the H6, should have been a J6. Okay. Alright, so again, that's taking this number and calculating delta epsilon, multiplying this by 2. So we have delta sigma over E, and then 2 times the quantity, delta sigma over 2 to the K prime to the 1 over N prime. Alright, so then our strain value would be this value. That's the start of this point right here, that tip. And we're decreasing in stress, so we have a negative sign. And we subtract off the delta epsilon. Alright, so let's copy and paste these down here. We'll paste those values there, Now we're going to add a series of x's and y's to our plot. And I'm hitting the shift and then end down, and that will take me to the bottom of that segment. Okay, let's see what that plot looks like now. Okay, looks like I've got something in the wrong with the wrong sign here. Let me check my calculation value. So these delta epsilons went negative. Oh, you know what I should have done? I should have taken the absolute value here. Okay, so that looks better. All right, now I have to do the absolute value. I can't rely on the sign because the we have part of that in the parentheses to the 1 over n power. So I have to use the absolute value and account for the sign over in this step right here. Let's see where I end up at and make sure that that is the same as what my calculation was in my for my hand results. Alright, so point B I said was at 002143 at minus 200, so I'm good. That looks like it's in the right spot. Alright, let's see. Let me go here. Here's my plot. So the next thing I'm going to do is I'm going to have a branch from B to C, minus 200 to 200. And I think what I'm going to do is I'm going to copy and paste this. My ending strain value is going to be this one. And my the end of the previous one, the beginning of this one, and then this is going to be minus 200. So I'm going to go minus 200 to positive 200. Okay, so my sigma is going to be minus 200. So let's do that, and then we'll take this to value of 200. We'll get rid of all this. And let's see if that's doing what we want. So our delta sigma, I think I'm going to have to update that, is I'm going to have to move this over to M4. So we have our delta sigma, our delta epsilon, we got our sigma value, and now we need to add instead of subtract, and it's going to be starting at L and not G. All right, let's add that to our curve. Okay. Yeah, we can make it look a little different by changing the scale of the axes, the aspect ratio. All right, now we're going to go from C to D. Four, 3, 5, 1, 9, 7. It's consistent with what I had right here. Paste that value in here. I'm starting off at plus 200. Need to change that to R. And at plus 200, I'm going down to, I think I said minus 100. Yep. So it's plus 200. Going down to minus 100, I can get rid of all this other stuff. Let's see if I'm calculating my delta sigma correctly. That looks okay. Now my epsilon, starting at Q, is my tip, and it is a decreasing, so I'm going to put a minus sign. Alright, let's see if I add that in here, what this would look like. And I messed something up. Let's see what happened. Looks like my strain offset looks a little weird. So the value, it should have ended up at that same value. The value of stress seems wrong. Let me take a look. I'm sure I just copied and pasted something over and didn't update it. No, I think I see what the issue is. This shouldn't be 390 right away. I need to copy and paste that formula as well. Okay. Alright, so that looks good. Okay, now here's where we have to think. We can't just blindly plug in a change from D to E of 600. Okay, that's not gonna work. First, we go from D back up to the level of C, so there's a change of 300. So we need to think about that and do that first. Okay, so let me grab the sketch. Okay, So we're down to here, we went to there, we went down to here. Now when we go from D, we don't go directly to A, we first do the branch from D to C. So that's going to be a change of 300. So we are currently at minus 100. And we go up to positive 200. So it is a range. Let's do it this way. So we're down at minus 100. And we go to plus 200. So our delta sigma is going to be the current value of sigma that we defined as minus 100 minus, now it's going to be W. Okay. I guess for the next iteration what I can do is I can get rid of the $sign in front of this one, and that'll copy over when I do the next batch here. So I have my delta sigma, my delta epsilon, and then now this one needs to be a increasing. And instead of that, I think we can do this. But instead of Q, it's going to be a V. All right. So now we're going to add this branch, the X values. Restart that. The X values and the Y values. Okay, so it brings it right up to that spot. Okay, now remember, when we go to complete the loop from B to A, we're doing this from C to A, but we're starting our tip at position B. So we're going to go the branch from B to A starting at C. Alright, so the tip we're looking at, these are the two tip points. Okay, will be this point down here. It's where B ended. So we want O to A down to B. So we're going to take these two values and paste those values in here. Okay, but now the stress that we're going to be at is from 200 to 500. So this value here is going to be 200. And we're going to go to 500. We're at an increasing strain, so it is going to be positive. Okay, so the delta epsilon right here is calculated based on accounting for that initial 200 and then 300 more from here to here. Let's see what this looks like. I might have made a mistake, but we'll see. Yep, I did not. Okay. All right, so that's kind of subtle. So this last bit is kind of subtle. My tip started down here, so I had to remember those points, but I only plotted from here to here to complete this gray, then the green branch. So these would be my hysteresis branches. Now if I wanted to, I could make these dots smaller. Maybe I'll do that here and turn the video back on. Okay, so I'm just going to select each of these and choose no marker. And then this is what my plot looks like. Alright, so you see this real thin looking hysteresis loop. And then of course the larger, thicker hysteresis loop. And again, this is just an example then of using Excel to calculate all of these. So again, it's probably a fine time to start thinking about how you would programmatically do this in Fortran, Python, MATLAB, and so forth for a sequence of points that you have in your time histories.